To multiply radicals. Multiply the coefficient by the coefficient to get the coefficient of the product. So let's look at if we had just 2 root 3 multiplied by 4 root 2. Multiply the coefficient by the coefficient. So which numbers there are the coefficients? 2 and 4. Multiply them together. 8. And then multiply radicand by radicand to get the radicand, the product of the radicand, I should say. So radicand are 3 and 2. 3 times 2? 6. So it's 8 root 6. That's it. Except simplify the radicand if it has a perfect square factor, which this one doesn't, right? 6 doesn't have a perfect square factor. So that's it, that's done. And then there's a note there. This only works if the index is the same on both factors. So this is a square root and a square root, so we can do this. If it was a square root and a cube root, you couldn't do it.
Okay.
That's what that note means. So, but because they're both square roots, no problem. And most of what we're going to be working with are square roots anyway. But that's as easy as it is.
Wait, what happens if it's a perfect square?
If there's a perfect square factor, or this is a perfect square inside the square root sign, then you need to simplify. And we'll look at a couple where that happens. So here's one, 2 root 5 times 3 root 2. Super easy, 2 times 3, 6, 5 times 2, 10, done. There's nothing there to simplify. 10 does not have a perfect square factor, so it's done. In the next one, the coefficient on the first factor is a 1 multiplied by 3, so it's just 3. And then 2 times 6? 12. This one's not finished. Because 12 has a perfect square factor of 4. 12 is 4 times 3. That 4 comes out and becomes a 2. So it becomes 3 times 2 root 3 or 6 root 3. You may not write down those steps, like here and here. If you can go straight from there to there, that's all right. But if you need to write it out, then write it out. When you have one like this, where you have like a monomial multiplied by a binomial, you have to use the distributive property. So we're going to do root 3 times negative 5 root 10, which is negative 5 root 30. And then root 3 times root 6, which is root 18. So you just do both of those multiplications. And then simplify if you can. 30 does not have a perfect square factor. No, but 18 does. So this will become negative 5 root 30 plus 18 turns into 9 times 2, so 3 root 2. And this last one, a binomial multiplied by a binomial. So we're going to have to use that distributive property. And how many things are we going to have to multiply here? A few. 4. 2 root 3 times root 3, which is 2 root 9. And then 2 root 3 times 4, which is 8 root 3. And then negative 1 times root 3, which is just negative root 3. And negative 1 times 4, which is negative 4. So this one does have a bit more simplifying to do. What do I do with a root 9? Simplify it. What does it turn into?
Just a whole number.
It turns into a whole number, right? Because 9's a perfect square. Take the square root of 9. 3. So this turns into just 2 times 3 for that first term. So that's actually 6 plus 8 root 3 minus root 3 minus 4. And combine like terms. 6 and negative 4 go together to make a 2. 8 root 3 and negative root 3 become plus 7 root 3. And there's the answer. So there's a little bit more to it than just what we started with multiplying coefficient by coefficient, radicand by radicand. Because you still have to bring in the stuff that you learned before, the combining like terms and the simplifying. But that's it.